X-ray crystallography is one of the most important techniques for analyzing the structure of molecules. Bragg's law allows the effect of specific atoms within crystals to be deduced. Simply put, individual spots on the X-ray diffraction pattern are directly related to the atomic structure of the crystals, which allows for the determination of the position of atoms within the crystal itself. In Dr. Gary Taylor's lab at the University of St. Andrews, researchers study the effects of specific proteins in viruses, such as influenza, and use X-ray crystallography to determine their structure. Their research into pathogenesis is used to develop novel drugs and vaccines targeting microorganisms. Postgraduate researcher David Owen is interested in salatidase, also known as neuraminases, which are found in viruses. The specific NAN-C salatidase that Mr. Owen studies acts within the lung. These enzymes cleave sialic acid residues from the surface of living cells, which reveal a binding domain critical in viral infection. The protein has a large molecular weight of approximately 80 kilodaltons and has two domains, the larger of which is a catalytic domain that cleaves sialic acid or glycosides from cells, the smaller of which is a carbohydrate binding domain. It is inherently difficult to encourage proteins to recrystallize as they have to be placed in appropriate conditions.
A cocktail of chemicals underneath a drop of protein, which will help the protein to precipitate out. If the nucleation of the initial formation of crystals is uncontrolled, then you end up with a huge number of tiny crystals, which are pretty much useless.
The method Mr. Owen uses specifically is that of the hanging drop method.
So there are a number of ways of controlling this nucleation. One way is to add an inhibitor of that. And I was bored, so I tried adding sugar-free iron brew.
He adds sugar-free iron brew into the recrystallization precipitant, which, strangely, inhibits the nucleation of the protein crystals. This results in the formation of solitary large crystals rather than masses of smaller particles, which in turn allows for easier structural analysis by X-ray crystallography. So, would other fizzy soft drinks like Coke have the same or similar effect?
I imagine Coke would probably not work because I think it uses phosphoric acid to control the pH in Coke, whereas I think iron brew is ferrous citrate, ferrous being where your girders come from. But having phosphate crystals, you'll get crystals of salt in your drop, and that of course is not protein, which is not what I want. But I'm sure any other number of fizzy drinks that did not contain phosphate would probably be okay. I think what I possibly discovered is we actually don't have any idea what chemical is going to be useful. We do not understand crystallography enough, why some proteins crystallize, why they crystallize when they do, or more often, why do they not crystallize. So I'm sure it's worth just trying many things. Hi, I'm David, and that was my life.